Hey everyone, welcome back. Today we are going to talk about one of the most common problems you will encounter when working with Spark, that is data skew. If you ever had a Spark job that seems to be stuck at 99% complete for hours, or one task takes forever while other finishes quickly, you are probably dealing with data skew. Let's understand what it is and more importantly, how to fix it. So what exactly is data skew? Imagine you have data spread across multiple partitions. In an ideal world, each partition has roughly the same amount of data, let's say 128 MB each. But here's what happens in the real world. When you perform operations like aggregation or joins, the data gets redistributed. And sometimes this redistribution is not even. You might end up with partition 50 MB, 45 MB, 52 MB, 500 MB. This 500 MB is the problem. That one huge partition is what we called data skew. Let me show you a real example. On the left, we have data before aggregation. Notice all four partitions are roughly the same size, nice and balanced. Now on the right, after we aggregated by city, look what happened. City A, B and C have small amounts of data, but city D has huge amount, maybe twice or thrice times as much. This happens when cities have different populations. If city D has twice the population of the others, it will naturally have twice as many records after aggregation. Small skew is ignorable, but large skews, they can kill your job's performance or even cause it to crash. Why is data skew such a big problem? First reason is the longer processing time. Job runs two times slower or more. And the next reason is high memory requirements. Skewed partitions need more RAM. And the third one is the entire stage waits. Slowest task determines the total time of the job. And the fourth one is out of memory errors. Out of memory failures can kill your jobs. And the fifth one is hard to diagnose. Root cause isn't always the obvious. Think about it this way. If city D has twice the data, processing time doubles for that partition, memory requirement doubles for that worker, and here's the kicker. The entire stage has to wait for that slowest partition to finish. It's like having a team where three people finish their work in 10 minutes, but one person takes 2 hours. Everyone has to wait. Even worse, if that partition is so large it doesn't fit in memory, you will get out of memory errors and your job crashes. This is really hard to diagnose because the error message doesn't say, hey, you have data skew. In our example, processing city D could take twice as long as processing A, B or C. Your entire job is only as fast as your slowest partition. Databricks uses something called adaptive query execution or AQE for short. Here's how it works. Spark looks at your partitions. It sees that partitions 1 to 4 are all around 40 to 60 MB, but partition 5 and partition 6 is much larger. AQE automatically breaks that large partition into smaller pieces. Now all partitions are roughly the same size. They all processes at similar speeds and your job completes much faster. The best part, you don't have to do anything. AQE is enabled by default in Spark 3.1 and later. It just works. This is one of the big advantages of using Databricks versus manually managing Spark. Many cloud data warehouses require you to manually redistribute data to fix skew. As we discussed, this is your first line of defense and it's enabled by default in recent Spark versions. If you are an older version or want to make sure it is enabled, you can set it explicitly in your notebook. For that, you can set these configuration: adaptive enabled as true and adaptive skew-gen enabled as true. AQ does three main things: handles data skew by splitting large partitions, collates small partitions to reduce overhead, optimize join strategies dynamically. Most of the time, this is all you need. How can you fine tune the skew detection? You can set these two properties, skew partition factor and skew partition threshold bytes. If skew partition factor is equals to 5, Spark compares size of each partition with the median partition size. If partition is 5 times larger than the median, it is an ideal candidate for being skewed. And skew partition threshold in bytes equals to 256 MB. This is the minimum threshold in bytes. Even if the partition is 5 times larger, Spark will not treat it as skewed unless it's also larger than 256 MB. So, to consider partitions as skew partition, these two conditions should fulfill. Now, while AQ handles most cases automatically, there are times when you might need to manually address skew. Maybe you are using an older Spark version, or maybe the skew is so extreme that you need additional help. We will be seeing more methods in the future videos. Here I will be showing you the live example of AQ. So here I have imported some of the libraries of the Python, and here in this function I just have disabled this adaptive enabled as false. So by default in the Spark 3.1 and in the later version we have the AQ enabled by default. So like to showcase the example I just have disabled it. Okay, then we have this trips data and this zone data. So in the data sets, I am having the data of the trips and the zone data. So trips data is in like in the Parquet format, and this zone data is in the CSV format. So I have loaded this data using the Spark method, Spark read.parquet, as well as the Spark read.option as a CSV format. Okay, so these two data is loaded here, and I am analyzing this data by zone and by borrow. So here I am getting the average trip distance by zone, and here I am just getting the average trip distance by borrow. So here if you can see that I have loaded this data from these two functions. I have joined this data on the PO location ID and the location ID, and if I just execute this function here, okay, so I'm just executing this function again. Okay, so if you see here, uh, this is like getting started here. So yeah, so this is the average trip distance by zone, and here I am getting the average trip distance by borrow. So the time took for execution of this complete code is like 15.43 seconds. And to check that Spark UI, we can come here, and if you see here we have this two jobs which ran on like 5 seconds, 6 seconds. Let's take an example of 6 seconds. So here we come across like 4 stages. In this 4 stages we are having this job that is taking like 4 seconds, and if I just open this, then in the event timeline we can clearly see that this current like partition is taking the too much time here. Now if I just go here, okay, and I have just here like enabled the AQE. So here I have enabled the AQE. I have have defined this property collision partition enabled as true. So what it does, it like reduces the partitions, shuffle partitions if it is required based on the AQE framework. And here are these three properties which we have already discussed in our previous slides. So if I just run this code, and again I'm running the same code that was here, I'm just running it again. So it's just like running it. So previously the entire code took the 15.43 seconds. Now if you come here and see, the same code is ran in just like 6.49 seconds. So we can clearly see the difference in the execution time. So if I just come over here and just come here, so these uh, these tasks are like, these are the newly created jobs in here. If you can see this, this all tasks take like 1 second, 2 seconds, 1 second. So if I just take the example of this task that is like taking the 2 seconds, if I'm just opening this, so it is having like just four partitions. So we have defined the coalesce partition. That's why it's like it just has the reduce the partition size to the like 4 seconds. If I just open this one, you can see all are having like 1 seconds, 1 second, and 1 second. So all executed in 1 second. And now I hope you understood how AQE solve data skew problem, and I will see you in the next video.